By now you think you know every way the air can kill you. Too little oxygen, and you go slow. Too much carbon dioxide, and you go stupid. Too much heat, and you cook. 3 dials, 3 ways to fail, and you have learned to read all of them. So here is the reading you are not ready for. On this world there is a fourth needle on the panel, and it does not measure a shortage of anything. It measures a presence. Something in this air is not missing. It is added on purpose by the planet itself, and it is here to switch you off. Look at the readout. Home today, carbon dioxide 420 parts per million, oxygen 21%, 15 degrees. Now here, 252 million years ago, carbon dioxide somewhere between 5 and 8,000 parts per million and still climbing. Oxygen down to 16. In the tropics, 10 degrees hotter than anything alive today has stood in. And then that fourth gauge, the one you have never needed before, twitching up off its pin. 3 of these you could, in theory, outlast. The fourth is why almost nothing here will. So where has the jump put you? You are standing on a reef, or on the bleached skeleton of one. The limestone crumbles under your weight, chalk pale and dead. The sea in front of you is neither blue nor green. It is brown, and it is still. And the smell coming off it is the smell of rotten eggs, thick enough to taste. Turn inland, and it is worse. Bare tree skeletons to the horizon, gray and limbless, standing in soil that has been stripped down to bare rock by rain turned to acid. Why is a whole world laid out like a mortuary? Because it is being killed right now from a single wound half a planet away. The geologist Seth Burgess dated this catastrophe with uranium locked inside tiny crystals and found something strange. In Siberia, lava had already been erupting for 300,000 years before the dying began. The lava, it turns out, was never the weapon. The killing started only when that magma punched sideways into buried coal and gas and salt and began to cook it, the whole eruption turning into something like an enormous coal-fired power plant, venting its exhaust into the only sky there is. Whatever lived here recently is not here now. You have arrived a little too late to see it, and a little too early to be safe. So what does this air take from you first? It takes your speed. At 16% oxygen, you are breathing the summit air of a 2,000-meter mountain at sea level, and your body does what it always does with thin air. It slows, it labors. Every small movement costs more than it should. Then add the heat, 10 degrees above a punishing modern tropical day, wet and unmoving. You cannot outwork it because sweat only cools you when air moves across your skin, and nothing here is moving. Where did the oxygen go? Paul Wignall has spent a career reading the rock of this exact event, and the water tells it better than the air does. Warm water cannot hold much oxygen, so as the sea heated, its depths simply stopped breathing. The deep ocean went anoxic, starved, dead, still. And that same drawdown reached up and thinned the very air you are now trying to pull into your chest. The sea and the sky are running out of oxygen together, and you are standing in the seam between them. So you are already slow, already laboring in a body that is quietly being rationed. And that is the easy part. Surely, though, you would still be thinking clearly enough to leave? That is the next thing to go. Carbon dioxide at these levels does not choke you. It fogs you. Somewhere past a few thousand parts per million, in sealed modern rooms, people measurably stop reasoning as well. Their judgment dulls, and they never feel it slip. You are standing in many times that concentration in open air. So the failures begin to stack, and they change kind as they stack. A moment ago, the problem was in your muscles. You were slow. Now it climbs into your head. The decision to turn from the brown sea, to find higher ground, the arithmetic of how long you can stay here, all of it now takes a beat longer than it should, and you do not notice the beat. The slowness in your body you might have pushed through. The fog in your mind is the thing that quietly decides you will not. And none of this, so far, is the fourth needle. This is only the part of the panel you already knew how to read. So what is that fourth needle actually measuring? This is where the world stops being a harsher version of anywhere you've been. Lee Kump and his colleagues worked out what a dead, oxygen-starved ocean does next. Once the deep water goes anoxic, a particular kind of bacteria takes over. Organisms that do not need oxygen at all, and that exhale hydrogen sulfide, the rotten egg gas you smelled the instant you arrived. In a healthy ocean, it stays trapped far below, harmless. In this one, it built and welled and finally broke the surface and poured up into the sky. And this is the turn the whole episode rests on. Everything that has hurt you so far has been a shortage. Too little oxygen, an atmosphere so thick with carbon dioxide that it clouds your thinking. Shortages you can, in principle, endure. Hydrogen sulfide is not a shortage. It is a presence, an active poison. And in high enough concentration, it does not slow you or fog you. It walks straight into your cells and shuts down the tiny engines, the mitochondria, that turn air into energy at all. The same molecule your own body makes in harmless traces is here in killing amounts breathing out of the sea towards you. So the danger was never really the three dials you knew, it was the fourth, the one that measures not what the world has taken away from you, but what it is actively pushing into you. So how far can a single wound reach? Look up, the haze that never lifts, the particulate that stings your eyes. Sarah Carmichael has argued that the Siberian eruptions were not only quiet floods of lava, their most violent, explosive phases blasted ash and salt high into the stratosphere, shredding the ozone that screens out the worst of the sun. So even the light falling on you is wrong now, harder, harsher, burning skin that the acid rain has already found. Now widen it out, but keep it about you, because a number this size is too easy to look past. 96 of every 100 kinds of animal in that sea will be gone. 7 of every 10 on the land. The reef crumbling under your feet is not a strange geological formation. It is the largest graveyard the planet will ever assemble, and you are standing on it the day it is being filled. There will be no true coral here again for 10 million years. The first reefs to crawl back will be built by little more than slime. You are, for a few hours, a witness to the closest the Earth has ever come to sterilizing itself, and the machinery doing it is invisible, half a world away, and has no idea you are here. So, how long do you have? Not long. This is the part where the Cambrian let you down slowly, across the length of an afternoon, almost gently. This world will not. The oxygen has you slow, the carbon dioxide has you stupid, the heat has you failing to cool, and under all of it, rising off that brown sea with every breath you take, the fourth reading climbs. You do not get an afternoon, you get hours. Maybe less if the wind turns and carries the sea's exhalation inland thick. There is no higher ground that fixes this, no holding still until it passes. The air is not merely empty of what you need, it is full of something built to end you, and it is topping itself up faster than your body can clear it. You sit down because standing has become too much, and the last thing that happens is the simplest thing of all. The engines inside your cells are told to stop, and they do. So why should the worst day in the history of life mean anything to you, standing safely 250 million years on the far side of it because of how it was done? The MIT mathematician Daniel Rothman studies the carbon cycle as an excitable system, a thing that shrugs off a slow nudge, but, pushed hard enough and fast enough, fires like a struck nerve. His line is almost unbearable in hindsight. Raise carbon dioxide by a little, slowly, and nothing happens. Raise it by 700 parts per million in a century, and the whole system fires. What you have been standing in is simply what firing looks like. And here's the part that should keep you awake. The Siberian traps took roughly 1 million years to release their carbon, and that was fast enough to do all of this. We are releasing ours perhaps 10 times faster. This is the far end of the story the Carboniferous began. That world spent 60 million years burying carbon and lifting the sky's oxygen into a gift. This one dug that same carbon back up, set it alight in a geological instant, and turned the gift inside out. Peter Branham puts the warning without a shred of comfort in it. The Earth, he says, does not care what caused the injection. It only cares how fast. You thought you knew every way the air could kill you. You were wrong by one. And the fourth needle, the one that measures not what is missing, but what is being added, faster and faster, into a sky we are all of us still standing in, is the only gauge on the panel that is moving today.